All right. Raise your hand. Any questions on yesterday's assignment? The lady? 11. The graph on the right shows the rate of change of the quantity of water in a water tower in liters per day during the month of April. If the tower has 12,000 liters of water in it on April 1, estimate the quantity of water in the tower on April 30th. Okay, so we have liters per day and I have days. If I have liters per day and days and I want to get, what is it I want to get? Just liters. What do I have to do with liters per day and day? I have to multiply. So that means I'm finding what from this graph? The what?
You're going to integrate.
I'm going to integrate. And what does a definite integral represent? Area under the curve. So I need to estimate. It wants me to estimate that right there. Okay. Now this one, there's going to be multiple answers. So you need to keep that in mind. And some of you won't like this problem because you have to estimate. But you need to get over yourself. You've got to be able to estimate. All right. How much area is each one of these boxes worth? 300. 300. So what I did was, this lower part I felt like was half of 2 boxes. And that's what I estimated it as. So 2 boxes is worth how much? 600. So half of that would be 300. So I estimated this as negative 300. Okay. Then I did the same thing for this little triangle piece right here. I felt like that was half of 2 boxes as well. This time, since it's above the x-axis, it's going to be a positive 300. Okay? Then I have 4 boxes that are completely full, so that's pretty easy. 4 boxes that are completely full are going to be worth how much? 1,200. And then I'm back to pretty much 2 boxes that are half full, so we're going to call that how much? 300. Okay, so that and that cancel, I end up with 1,500. Now, what does 1,500 represent? Area of the curve, but applied to this problem, I've got to add the original. So what I'm wanting to know is, this is how much more water was added to the tower, is what I'm wanting you to understand. So this is the amount of water that was added to the tower. What type of number would this be if it was water that was taken away from the tower? It would be negative. So it would tell you the amount that's taken away. So this is the amount taken away or added. And as John Ryan said, we started out with 12,000. So that means we're now looking at 13,500 liters. Okay, and again, we went back to the rates. We decided that we need to multiply together. Anytime I have to multiply my rates, that means I need to do what? I need to integrate. Okay, and if they give me a function that I can integrate, then that's what I'm going to do. If I don't have a function that I can integrate and I have a graph, what are we going to do? We're going to get area under the curve. Very good. Anything else?
What is answer number 1?
Anybody have that?
Is it 32 over 3?
I don't have it. I don't have my answers with me. 32 over 3.
So what's that the decimal? Like
10.66.
10 something. Yep, 10.666. She's correct. What else? John Ryan? 13. Alright, I figured we get this one asked. Alright, so they're giving me f of give me f of 2 equals 3, and we want to sketch f of x. Okay? So I know f of 2 equals 3. What are some other x values I can find y values for? Raise your hand, please. Don't blurt them out. What are some other x values I can find y values for? Jennifer? 0. 0, 6, and 8. Very good. How'd you pick those out? That's where our critical points are. So here, 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 and here. So I've already got f of 2. So I should be able to find f of 0. I should be able to find f of 6, and I should be able to find f of 8, because those are my critical points. Very good, Jennifer.
Find F2.
I've already got f of 2. They gave me f of 2. All right, so that means I need to set up integrals to find it. If I'm going to find f of 0, what's that integral going to be?
0 to 2.
It's not going to be 0 to 2. It's going to be, anybody else? It's going to be 2 to 0, and I need to have the 3 out front. Say it again. I will here in a second. I'm just wanting to originally get it set up before I change that. Okay, again, why is this 2 down here? That's what they gave you. Why is this 0 up top? That's what I'm looking for. We've got to get that straight. Okay, and then why is it 3 out here? That's the y value they gave me. You got to get that right every time. Yes.
Why wouldn't 0 to 2 work? You just switch it to
Well, I'm getting ready to switch it.
Oh, okay.
But you always want to start with this. What they give you goes here. What you want goes there. Then I can switch it. So if I switch it, then this changes to a minus, and this changes to 0 to 2. All right, so it says that area is 2, so that means f of 0 is going to equal 1. Because 3 minus 2 gives me 1. All right. So we go 3 plus, again, 0 is what they gave me. 6 is what I'm wanting. All right. It should be 2, sorry. Thank you. All right, so from 2 to 6, it says it's 7, but since it's below the x-axis, that means it is negative. So 3 and a negative 7 give me negative 4. This one, we're going to 8. So 8's on the top. Okay, I've already got the negative 7 and then the 4. So we're going to have 3 minus 7 gives me the negative 4, and then negative 4 plus 4 means that this is equal to 0. All right, so now we have everything we need. Negative 4 is my lowest y value. 3 is my highest y value. And I plot my points. So 0, 1. 0, 1 is there. 2, 3. 2, 3. 6, negative 4. 2, 3, 4, 5, 6. And negative 4. And then 8, 0. Alright, everybody with me to that point? Alright, raise your hand. What's the next thing we need to look for? Mallory? Concavity, more specifically? Points of inflection. And where are those points of inflection located? Nope. At the maxes and minimums of the derivative. Alright. So, again, where is my max on this one? 1. So I'm going to go to 1. I'm going to go up until those two things meet. So we're going to meet about right there. My next one looks like it's about right here. So that is 1, 2, 3, 4, 4.5. So 1, 2, 3, 4.5. Connect and connect. I'm going to say it's right there. Again, you cannot be exact on these. Just get close. And then my last one is at 7. So I connect and I connect. I'm going to put it right there. Okay, now we need to look at the concavity. So between 0 and 1, what's my derivative doing? Increasing, so that means my concavity is concave up. So I need to draw something that's concave up. Make sure I can tell you have some curvature. Do not draw a straight line. A straight line has no curvature, has no concavity. All right, between 1 and 2, what's my derivative doing? Decreasing, so that means we are concave down. Make sure I can tell that. All right, between 2 and 4.5, what are we doing? Decreasing, so that means we are concave down. Between 4.5 and 6, increasing, so we are concave up. And then between 6 and 7, increasing, so we're still concave up. And then between 7 and 8, decreasing, so we are concave down. That's some good stuff. Because if we have the ability to do this, I mean, we're in really, really good shape if we can put all that together. Because we're putting several different things together right there. It's good stuff. All right, let's do one more, and then we'll move on to today's stuff, if we have one more. Anybody? Do we need to look at the first ones out? Everybody else is good. 12. 12. A cup of coffee at 90 degrees Celsius is put into a 20 degrees Celsius room when T equals 0. The coffee's temperature is changing at a rate of R of T equals negative 7 e to the negative 0.3 T. So since my rate is negative, what does that mean is happening to the coffee? It's cooling. Okay. If this was positive, that means my coffee would be getting warmer. Okay. With T minutes, estimate the coffee's temperature when T equals 10. So raise your hand if you can set this up for me.
Would you do it? Would 0 be your X value that you have, or your Y value that you have?
That's the X value I have. So I know that there's a 0 there for sure.
10 be on top?
10 would be on top.
And then you put the R of T.
R of T is on the inside.
Would it be 90 plus?
90 plus is on the outside. There it is. Plug that in your calculator. There's your answer. Good job, Zach. Anybody do that? What'd you get, John Ryan?
67.828 degrees.
Now, what would be a red flag if you got a degrees that was larger than 90? Can't happen because what should be happening? It should be cooling. So I need to make sure my answer, always make sure your answers are logical.
So does the 20-degree room not mean anything?
No.
Well, if it was in like a 10-degree room, would it not cool off any faster?
We would have a different rate.
Oh, okay.
The 20 degrees has something to do with the rate, how they found the rate. And that's something we'll deal with later on in the year. It's called Newton's Law. It's pretty cool.
I would have gotten mine.
How did they work on it? She was saying.
Zach, one of you needs to go and go.
Where?
Your trip to the Capitol.
Until after that, right?
Yeah.
No, they said they're calling you at 12:30. Well, I was told.
Yeah, that's what Miss Bobby was saying. Why are you going to the Capitol?
For the day 23.
They do that?
Well, it did this year.
This?
Yeah.
Same stuff. Same type of stuff. What do you mean exactly the same?
You handed it to me twice.
When did I give it to you?
Does it start work or now?
Both.
Can I go ahead and give the review today? Do you have any more M&Ms?
After we get done working this problem, I'll give you some more.
Did you try the cookie test?
I did. It was good.
Yeah. They're like addicting. Like you can.
Your presence interruptions this time. Football players are traveling to the Capitol. You know who you are. You need to hustle up and be fully out now. Football players traveling to the Capitol need to be released from class now. Thank you.
Are all of y'all not going?
All right. So what we're doing today? Listen, please. Listen. There's nothing really new with what we're doing today. It's just applying our previous knowledge to problems that look like this problem does. That's all that's happening. Everything we're doing, Zach, let's go if we're going. See you. All right, so it says g of x equals the integral from 0 to x of f of t. First thing it wants me to do is find g of 0. If this is g of x and I want to find g of 0, what am I going to do with 0? Plug it in for x, which is going to go right there. Well, what happens when I plug in 0 for x? It gives me 0. So g of 0, we can automatically see is 0. Okay, so then we want to find g of 3. Same thing, plug in 3. So that means g of 3 is the integral from 0 to 3 of f of t dt. So how am I going to find the integral from 0 to 3 of f of t dt? I'm going to go to the graph. Okay, what shape do I have here? Quarter circle, which is 1/4 pi r squared. What's my r? 2. I square it. Gives me 4. So that means that section right there is worth pi. So that means g of 3 is pi. Everybody with me?
It goes to baby triangle.
Oh, sorry. Thank you. All right. Then how much is that little triangle? That little triangle is 1/2. Thank you. It would be negative. I'm struggling.
Are you good?
I'm good. At least you guys are on your game.
Well, always.
All right. G of negative 2 equals the integral from 0 to negative 2. All right. What do we not like about that? It's not in order. So what do we do? Flip it. Make it negative. Alright, so that's another quarter circle. We already know that quarter circle is worth how much? Pi. So that means it's going to be negative pi. So what do you notice happens? Our starting point is the x value of 0. What do you notice happens when you go backwards?
It's negative.
You have what it's flipped. So if it's above, it becomes negative. If it's below, it's going to be positive because you're doing it backwards. When you do it backwards, that negative comes out there, so that flips everything. All right, g of 5. All right, so I know I'm already at pi minus 1/2, and then but what's going to happen to those two triangles? They're going to cancel, so that's also going to be pi minus 1/2. G of 3 and g of 5 are going to be the same thing. Okay, so that stuff is what we did yesterday. That's similar to what we did yesterday. All right. Next thing, find all values of x on the open interval negative 2 to 5, in which g has a relative maximum. So how do I look at that and find the relative maximum? This is bringing it back a little bit. So Lonnie, look for critical points. Critical points occur when touch the x-axis, and a maximum is going to happen when changes positive to negative. So that means my relative maximum is at 2. Now, and because why? Now, there's one other thing we have to show right here. We have to show the relationship between G and F. What is that relationship?
It's above the
G is above F, so that means F is what to G? The derivative. So you have to show that G prime of X is F of X. You have to show them that you know that. Okay, you have to show them that. Now, once you've done it, you don't have to do it on any of the other problems that are associated with this problem. Once you've done it, then you've done it. All right, C. Find the absolute minimum value of G on the closed interval from -2 to 5 and the value of X at which it occurs. Justify your answers. So this goes good with our starter problem today. So what do we do here? Find where the derivative is equal to 0. So where's the derivative equal to 0? 0. -2, 2, and 4. Okay? And then what do I need to do with those values? You need to plug them in. So we said G of -2, we said G of 2, we said G of 4. What else do we have to consider? The endpoints. So what's in one endpoint we haven't got yet? 5. So I also have to talk about G of 5. Now we should know quite a few of these already. Which ones do we already know? G of 5 is pi minus 1/2. What else do we know? G of 2 is what? Negative what?
No, G of -2 is
Negative pi. Have we done G of 2 yet? No, but it should be pretty easy to figure out. It is pi. G of 4? Pi minus 1. Everybody good on finding G of 2 and G of 4? Even though we haven't done those already? No? Just look at your area between 0 and those numbers.
Okay.
So 0 to 2 is just that quarter circle, which we said was pi. And then when I go to 4, I got that -1 down below. So it'd be pi minus 1. Okay, so that means our absolute minimum value is negative pi. Negative pi is going to be my absolute minimum value. So ABS minimum is negative pi at x equals -2. Do I have to do any other justification? No. Why? No. What type of extrema is this? Absolute. Remember, absolute, your work is your justification. Okay? You only have to say stuff if you're finding what type? Relative. All right, write an equation for the line tangent to the graph of G at x equals 3. So what do I need to be able to write a tangent line? Slope. Where do we get slope from? The derivative. What's the derivative of G? F. So that means I need to know what f of 3 is. So what is f of 3? Everybody agree that it's -1? Just what's the y value at the x value of 3? -1. Okay, so then I need y minus the y value that goes with 3. Do we know the y value that goes with 3? Yes, what is it? Pi minus 1/2. Go ahead and put that in parentheses. Then I have my slope, which we said was -1, and then x minus my x value. I do not have to clean it up. That's perfectly acceptable for a tangent line. Questions on what we did there? If people get hung up, it's usually getting hung up finding that value. Everybody good on understanding why that's my slope?
So why did you put? Okay, never mind.
Ask your question.
Why did you put the -1 in for y?
Why did I put my -1 in for y? Because remember, f of 3 is equal to g prime of 3. So if I'm plugging into the derivative, that means what I get out is slope. So there's my slope. And when I plug 3 into g, this is what comes out, so that means that's my y value. Alright, this one should be easy. Raise your hand. Find the x-coordinate of each point of inflection of the graph of g on the open interval from -2 to 5. Who's got points of inflection for me? Raise your hand. I know everybody knows what they are. Come on. Hunter.
So there are points of inflection at x equals 0 and x equals 3.
Because
they change from increasing to decreasing or vice versa.
Alright, I don't like the word they. What's
F
that?
changes.
There you go. Very nice. Remember, your points of inflection, if you're looking at the derivative graph, are always going to be what? Your maximums and minimums of your derivative. What do I have at 0? Maximum. What do I have at 3? A minimum. That's why they're my points of inflection. Got it? Alright. Range. What is it asking for on range? What is it wanting to know? Y values. And what about my y values? Right. What's the smallest one? What's the biggest one? So all I have to do is go back to C, and all the information I need should be in C. What's my biggest y value? What's my smallest y value? We already said the smallest was what? -pi. Okay. And then which one of those is my largest? Pi. So that means all of my y values have to be where? Between those two. Have to be between -pi and have to be between pi. Got it? So again, this is just tying everything in. There's a lot of stuff right there on that one problem. Let me make sure there's not one more I want to do. Okay, one more question on this problem that I can see you being asked later on in another one of these questions on this assignment. Another question you might be asked is, when is G increasing? When is G increasing and why? So raise your hand if you can tell me when G is increasing and why. Elias?
From -2 to 2 because f of t is positive.
Alright, don't say f of t. It's going to be, just say f or say f of x. Okay, my variable needs to match this. Okay? Because f was what? Positive. Everybody agree with that? Okay? When is G, well, when else? There's another spot.
4 to 5.
4 to 5. Okay? So then, Jarrell, when is G decreasing?
From 2 to 4.
From 2 to 4 because f is negative. Okay. What can you tell me about G double prime at 3 and why? And then I'm done with you once we get that question answered. What can you tell me about G double prime of 3 and then why? Raise your hand. Give me just a second. Let me see if I can get anybody else. Not negative. No. All right, what do you got? No. John Ryan?
Is it 0?
Nope. What can you tell me about G double prime at 3? What is the graph doing at 3? What do I have there? I have a cusp. And if I have a cusp, then that means the derivative of that function is not differentiable. That means the derivative is undefined. So G double prime of 3 is undefined, is what I'm wanting to get out of it. Okay. All right. That covers that. Should give you enough information to finish up that assignment.